Hi everyone, so last lesson we looked at calculating the total surface area of basic objects, and we learnt how to use the formulas. We understood what each part of the formula represents and how to manipulate it according to the scenario that we've been given. What we're going to focus on today, however, is calculating the total surface area of non-basic objects. And what do we mean by non-basic objects? It's objects like these where there is no defined formula and you kind of have to problem solve to calculate the total surface area of that particular object. So it's nothing that's on this page. It's things like pyramids and prisms. So let's have a look at those. Now, when we're looking at calculating the total surface area of non-basic objects, so we don't actually have a formula for it, we need to make sure that we can identify all the sides that the particular object has. So we're going to start with this one here. This is page 2 of your notes. And we can see that an object like this has 5 sides. There is one side, the base, which is a square base, and the surface area of a square, or an area of a square, is length times width, or length times length, which is 3 times 3, and we get 9 meters squared for the base of the pyramid. Now we can also see that we have 4 triangular faces. So I've written the triangular face here and I'm multiplying it by 4, and we know that the base is 3 and the height of the triangle is going to be 4. So we can substitute what we know, base and height, into the formula half base times height, and remind ourselves we're going to multiply it by 4 because we have 4 of those faces. So proceeding with the formula, half times the base, which is 3, times the height, which is 5, all multiplied by 4, we're going to get 7.5 times 4, and we're going to get a total surface area of the triangles of 30 meters squared. So the total surface area of the object, so the entire pyramid, the 4 triangular faces plus the bottom face, is going to be this figure plus this figure there, which is going to be 39 meters squared. Nice and easy. In our next example, we also have a square base pyramid, slightly different though, but we'll have a look. So once again, let's recognize that this square base pyramid has 5 sides. One of the sides is a square base, which is this bottom one here. And we know that the square base has a length of 10. So we know that the area of this square is going to be 10 times 10, which is 100 units squared. The units aren't given to us, but we still need to make sure that because we're referring to area, we need to put in units squared. We can also see that we have 4 triangular faces. Now, what do we know about this triangular face? We know that the base is 10, but what is the height? Now, the height's not actually 15 units. The height, 15 units actually represents the height of the entire object, but what we actually want is the height of one of the faces, one of the triangular faces here. So we actually want to know, well, how tall is this triangle? Not the object, but the actual triangular face. Now, we don't have that figure, but we can always use a formula to work it out. In this case, because the height of the object is given, we can form a right angle triangle with the face, and we can use Pythagoras to solve for the height of this triangle here. Okay, so we're going to find out what this is. So to do that, let's draw this triangle out. So we have a right angle triangle. The height of this is 15. The base is 5 because it is half of the 10 that's there. What we want to find out is this side here. That's going to be the height, I'm going to name it H, height of the triangular face. Using Pythagoras, C is equal to, C is the longer side, or the hypotenuse, C is equal to the square root of A squared plus B squared. That's C. Let's assume that's A and B. Let's replace everything in. So H would be equivalent to the square root of 15 squared plus 5 squared. And let's see what we get here. Square root of 15 squared plus 5 squared. So we get 15.8114. I'm going to leave it to 4 decimal places because it's not my final answer and I want to be as accurate as possible at the end. So we know that the height of the triangle of the triangular face is 15.8114. Okay, that one there. Now, we have to calculate the area of a triangle. Formula is half base times height. Base is 10, so it'll be half times 10 times the height of 15.8114. And I know that I'm going to multiply all that by 4 because I have 4 of them. So let's just save this answer there, and I'm just going to multiply it by a half and multiply it by 10. And then I'm going to multiply it by 4 because I have 4 of those faces. So all the 4 triangular faces combined is 316.2277 units squared. And so the total surface area of the entire object, so the 4 triangular faces and the base, will be that plus that, and to 2 decimal places would be 416.23 units squared. So that's 2 decimal places or 5 significant figures. All right, now moving on to a triangular prism like this. Okay, so when you see something like this, there are 2 ways you can do it. You can draw the net if you're really comfortable with drawing net. So you can open the object up and you'll get something like this. Make sure you label all the dimensions. And what you would do is you find the area of each of the faces and then you'd add them all up. Now, if you're not comfortable drawing nets, what you can do is just draw the faces individually. So let's go ahead with that because you've already got this in your notes. What would you do if you can't draw the net or if you have problems drawing the net? What I would do is I'd recognize that, look, I have a triangular face here. So I'm going to draw out that triangle. And I know I also have 2 of them. There's one at the front and one at the back. And what do we know about this triangle? We know that the base is 9 centimeters. And we know that the height of the triangle is 4 centimeters as given to us by this here. I don't really care about this side and this side of the triangle because that's not going to help us in terms of calculating the area. So I know that the area of this triangle is going to be half base times height, and I have 2 lots of them. All right. Then I can see that I have 3 rectangular faces. I've got a rectangular face here, one on this side, and also the one on the bottom there. So I'm going to pull the faces off one by one, starting with this big one up here. What do I know about this big rectangular face here? I know that one of the sides, or 2 of the sides, is 8.1 centimeters in length. And I know that the other side is 7.2. Okay, that's rectangle number 1. Rectangle number 2, let's look at this one that's been hidden there on the other side where we can't actually see. I know that the length of this rectangle is once again 8.1. 8.1 because it corresponds to that there. And then I also know that the side lengths of those triangles is 4.5 centimeters. Okay, and then later on we're going to do length times width to work out the area. The final one, another big one, is the one on the bottom, and I can see that this big one here has a length of 8.1 centimeters and a width of 9 centimeters. Okay, and all we do now is work out the area of the faces individually, and we add them all up to find the total surface area. So let's do this: half times base times height times 2. That's going to be 36 centimeters squared. Okay, 2 lots of them, each of them being 18 centimeter squared each. We have this one here, 7.2 times 8.1, length times width, 58.32. We have this one here, 8.1 times 4.5, 36.45 centimeters squared. And finally we have 9 times 8.1, that final one there, which is 72.9. And then so the total surface area of this object is the sum of all those faces, the 5 faces that we have. So two triangles and the 3 separate rectangles there. So we can just add them all up. 36 plus 58.32 plus 36.45 plus 72.9. And total surface area is going to be 203.67. Okay? Or you can do it this way, give you the same answer anyway. All right, let's look at the total surface area of this object here. Now remember, we can look back at our formula sheet for the total surface area of a cylinder. And I've lost it. Oh no, it's here. Okay, so we know that if we have a full cylinder, we can use the entire lot. But I can see here that we've only got a quarter of a cylinder. And not only do we only have a quarter of a cylinder, we also have to consider the extra 2 rectangular faces there. So we have 2 rectangular faces there and there, this one and that one. They should be identical. The radius is 2, so that's going to be 2, and the height is 6. So it's going to be 2 times 6, which is 12, and we've got 2 lots of them. So I'm going to times it by 2 again, and that will give me 24. That's for the 2 rectangular faces. And then all we have to do is use this formula, but we're only going to take a quarter of it. So it'll be 2 pi r squared plus 2 pi r h divided by 4, because we've only got a quarter. Put all the parameters in, and then make sure that we add the 2 rectangular faces in there. I'll let you give it a go, and in the next video I will tell you the answer to that one.